We're going to run through AP Prep problem number 5, or I suppose it was actually number 6 from the AP exam it was on. This is a really nice problem. It's a little bit more recent. It's a little bit more complicated on the surface, and yet it's exactly the kind of problem that you should really want to show up on the AP exam, because the calculations in the grand scheme of things are really relatively simple compared to a lot of the other calculations. And that's why I really like these chart problems. One of the challenges to the chart problems is that you don't typically see things that look very much like what you would see in a textbook, and you're certainly not going to see anything like this in a college course. So these are kind of AP specific problems. Good understanding involved, but a lot of different things going on. So a lot of times what they're going to do here is they're going to have functions represented different ways. The function can be represented in a table. So we have information about function g here and g prime. We're not going to use all that data, but we'll probably need g values at a couple places and g prime values at a couple places. We have a graph of h, okay, so we're going to have to implement visual concepts of things having to do with graphs. And then we have another function here, f, which means that we're going to have to show computational aspects of things with an actual function. All right, so let's go ahead and take a look at part A. Part A says to find the slope of the tangent to the graph of f when x is equal to pi. Okay, well, we know that the slope of a tangent line is really just the derivative at a particular point. Now, there are a lot of functions here. You kind of got to sift through it, but it turns out they're talking about function f here. Okay, so here's function f. It's cosine of 2x plus e to the sine of x. We just need to find the derivative at pi. Okay, so I'm going to go over here to paper. Let's see. F is cosine of 2x plus e to the sine of x. All right, we're just going to take the derivative here, and that's a pretty basic derivative. Derivative of cosine is negative sine. Inside function doesn't change. Remember, you have to multiply by the derivative of the inside function. And then the derivative of e is itself, but you do have to multiply by the derivative of the inside function. Derivative of the inside function is cosine of x. So again, one of the nice things about the free responses is your derivatives tend to be a little easier. They're never going to give you a derivative that simple in the multiple choice part of the AP exam, which I guess in 2020 you don't have to worry about anyway. We're trying to find the slope of the tangent line at pi. So we're going to substitute in pi, and we're going to be done with this. So anyway, this is going to be negative 2 sine of 2 pi plus cosine of pi e to the sine of pi. This was intended to be done without a calculator. Hopefully you kind of know that your sine function crosses the axis at 0 and pi and 2 pi. And hopefully you know that your cosine function is shifted over a little bit. It is going to cross the axis at pi over 2 and 3 pi over 2. And anyway, that means it'll hit a minimum at pi. So hopefully you know what those basic graphs look like. Or another option is the unit circle. Remember, for the unit circle, sine of an angle is the y-coordinate, and cosine of an angle is the x-coordinate. Could be a really quick way to do this as well. So anyway, a couple different ways to do this. Okay, starting out, sine of 2 pi. So I would just think about the sine graph. Sine of 2 pi is going to be 0, okay? Or you could go to the unit circle. 2 pi is 360 degrees, and so that'll come back around to this point right here. You want the y-coordinate. The y-coordinate is 0. So this whole thing here is going to become 0, okay? Next we need cosine of pi. So if you think about the cosine graph, cosine of pi is going to be negative 1. If you don't know what the cosine graph looks like, you can come down here. Pi radians, 180 degrees, would be over here. Remember, cosine is the x-coordinate. You can see you're going back 1 unit on the unit circle there. So cosine of pi there would be negative 1. And then sine of pi, you can come back to the sine function. Sine of pi is going to be 0, or you could go to the unit circle. Sine of 180 degrees, you want the y-coordinate there, and the y-coordinate would be 0. So be careful there. E to the 0 power is actually equal to 1. All right, so you're going to get negative 2 times 0, which is just 0. You're going to get negative 1 times e to the 0, which is going to end up being an answer of negative 1, okay? So I would write down that f prime of pi is equal to negative 1, And again, I think that kind of work would probably be appropriate. If we take a look at the scoring guide here, remember you're trying to get about 6 out of 9 if you want to be at a 5 rate, and we picked up 2 points there, okay? And chances are pretty good. I think if you got the derivative right, they would probably give you 1 out of those 2 points, and obviously substituting in, you would get the other points. All right, so not terrible. Let's go into part 2. Part 2 says, let k be the function defined as k equals h of f of x. We want the derivative of that, okay? So this is something that may look a little bit strange. This is something that I actually really kind of like, especially for those of you who make a lot of mistakes when you're doing derivatives. This is kind of nice. Basically, you're trying to take the derivative of h of f of x. And remember, they gave you a bunch of information about h and f. But I really don't think right now, because you've got a table and you've got a picture of a graph and you've got a function, you're not going to need to write the equation of function h or anything like that. Work with your general equation, okay? Think about how you take a derivative, okay? If I took the derivative of sine of 5x, for example, what do? You take the derivative of the outside function, the inside function doesn't change, and then you multiply by the derivative of the inside function, okay? Same thing here. We've got an outside function, so take the, and remember I'm taking the derivative of this whole thing. So take the derivative of the outside function, it's just h prime, okay? Inside function doesn't change when you take a derivative. And then the chain rule says you have to multiply by the derivative of the inside function. So we'll multiply by f prime. They love this on the AP exam, and that's so much easier than memorizing a derivative rule. Now, they do ask you to follow up here. They want us to find k prime of pi, okay? So we want to substitute pi into this. So we actually want h prime of f of pi multiplied by f prime of pi. Well, if we did the previous part right, we already figured out that f prime of pi is -1, okay? So we know that, okay? Over here, this is really an algebra 2 question, at least at the start. It's a composite function, so we need to evaluate f of pi, okay? And we can go back to the original function. The original function was cosine of 2x plus e to the sine of x. So that's going to be cosine of 2 pi plus e to the sine of pi when we substitute all that in, okay? Cosine of 2 pi, if you look at the cosine function actually at 2 pi comes back and hits a maximum again of 1. It's gone through 1 full cycle. Or you could think 2 pi is 360 degrees. You want the x coordinate there for a cosine. That's going to be 1. So it looks like it's going to be 1 plus e to the 0. And e to the 0, of course, is just 1. And so that whole thing is just going to equal 2. All right? So it looks like we're finding h prime of 2 and then multiplying it by -1. Okay? Well, h prime of 2. What's going on with h prime of 2? Well, if you go back to the original graph, you'll notice function h is this graph here. Okay, we want h prime. We want the derivative of h at 2. Well, the derivative is just a slope. And notice it's a super easy slope to find because it's a straight line. So they love these problems where you're using calculus concepts, but you're really using some really basic algebra here. Anyway, if you count the rise and the run there, that slope is -1/3. So the derivative there at that point where x is 2 is -1/3. Okay, so we have -1/3 times -1, and that looks like that's going to give me an answer of +1/3. So again, we haven't done any difficult calculus here. We've had to sift through a lot of things, but the basics have been pretty easy. Now, let's go check this and see. I certainly could have made some kind of mistake here. All right, we get an answer of 1/3. You'll see that they show almost exactly what I showed. You get a point for the derivative, and you get a point for substituting in. So we're at a 4 out of 9 now. We're already at a passing pace, and we've barely done any, really high-level calculus. The second video, I'll look at the second half of this.